term prime mover is not explicitly defined in the 2005 edition of the International Building Code, or IBC. However, the IBC does contain provisions related to prime movers in several sections. Section 407.1 requires that prime movers be installed in accordance with the manufacturer's instructions and the applicable provisions of the IBC. This means that before installing a prime mover, the installer must carefully review and understand the manufacturer's specifications and guidelines for proper installation. These instructions typically cover aspects like foundation requirements, ventilation needs, exhaust system design, and electrical connections. Adhering to the manufacturer's instructions ensures that the prime mover operates safely and efficiently and maintains its performance specifications over its intended lifespan. The applicable provisions of the IBC refer to various other sections within the code that may pertain to the installation of prime movers. These sections can cover a wide range of topics, including structural requirements for supporting the prime mover, fire safety measures, ventilation and exhaust requirements, and electrical safety standards. For example, if the prime mover is installed on a rooftop, the IBC structural provisions would dictate the necessary load-bearing capacity of the roof structure. Similarly, if the prime mover uses flammable fuel, the IBC fire safety provisions would mandate specific fire-resistant construction and fire suppression systems. Understanding and complying with all relevant IBC provisions is crucial to ensure the safe and code-compliant installation of a prime mover. Section 407.2 requires that prime movers be located in a dedicated room or space that is separated from other occupancies by fire-rated walls and ceilings. This requirement aims to isolate the prime mover from other areas of the building to minimize the potential for fire or noise to spread. A dedicated room or space provides a controlled environment for the prime mover, facilitating maintenance and reducing the risk of accidental interference. Fire-rated walls and ceilings are essential for containing a fire within the prime mover room, preventing it from spreading to other parts of the building. The fire assistance rating, typically expressed in IRAs, indicates the length of time the wall or ceiling can withstand exposure to a standard fire test. The specific fire resistance rating required by the IBC depends on factors such as the size and type of the prime mover, the occupancy of the surrounding areas, and the overall fire protection strategy of the building. Proper construction of fire-rated walls and ceilings involves using approved materials and construction methods that meet the specified fire resistance rating. This includes ensuring that all penetrations through the walls and ceilings, such as for pipes or ducts, are properly sealed with fire-stopping materials to maintain the integrity of the fire barrier. Section 407.3 requires that prime movers be equipped with an automatic shutdown system that is activated in the event of a fire or other emergency. This requirement is a critical safety measure designed to prevent further damage or injury in the event of an emergency. An automatic shutdown system is designed to automatically stop the operation of the prime mover when a fire is detected or other emergency conditions are sensed. This prevents the prime mover from continuing to operate and potentially exacerbating the emergency situation. The shutdown system typically consists of sensors, control logic, and actuators that work together to detect an emergency and safely shut down the prime mover. Fire detection sensors, such as smoke detectors or heat detectors, are strategically placed in the prime mover room to detect the presence of a fire. Other types of sensors may be used to detect other emergency conditions, such as excessive temperature, pressure, or vibration. The control logic, typically implemented in a programmable logic controller or other electronic control system, monitors the signals from the sensors and initiates the shutdown sequence when an emergency is detected. The actuators are devices that physically shut down the prime mover, such as by closing fuel valves, disconnecting electrical power, or activating brakes. The design and implementation of an automatic shutdown system must comply with relevant safety standards and codes, such as those published by the National Fire Protection Association, or NFPA, and other organizations. The system should be regularly tested and maintained to ensure its proper operation in the event of an emergency. In addition, the IBC references the National Fire Protection Association or NFPA 37 standard for the installation and use of stationary combustion engines and gas turbines. NFPA 37 contains specific requirements for the installation, operation, and maintenance of prime movers. NFPA 37 provides comprehensive guidance on the safe installation and use of stationary combustion engines and gas turbines, which are commonly used as prime movers in various applications. The standard covers a wide range of topics, including location, construction, ventilation, exhaust systems, fuel systems, lubrication systems, and control systems. NFPA 37 specifies minimum clearances between stationary combustion engines and gas turbines and adjacent combustible materials. This is to reduce the risk of fire. It also provides requirements for the construction of engine rooms or enclosures, including fire resistance ratings, ventilation, and access. The standard includes detailed requirements for ventilation systems to ensure adequate air supply for combustion and to remove exhaust gases. It also specifies the design and construction of exhaust systems, including materials, routing, and termination points to prevent the buildup of hazardous gases and minimize noise. NFPA 37 addresses the safe storage, handling, and distribution of fuels used by stationary combustion engines and gas turbines. This includes requirements for fuel tanks, piping, pumps, and other fuel system components. The standard also provides guidance on the lubrication of engines and turbines, including the selection of appropriate lubricants and the design of lubrication systems. NFPA 37 includes requirements for the control systems of stationary combustion engines and gas turbines, including starting, stopping, and safety interlocks. This helps ensure safe and reliable operation. Compliance with NFPA 37 is essential for ensuring the safe installation, operation, and maintenance of stationary combustion engines and gas turbines used as prime movers. It helps protect people and property from the hazards associated with these types of equipment.